welcome to episode number 8 of The Display Show. My name is Brian Berkeley, and I'm your host for interactive discussions with key display industry leaders and influencers. Today's guest is Roland Wooster. Roland works at Intel, where he is principal engineer and display and platform technologist within Intel's client domain architecture and strategy group. Among other activities, Roland is quite active in display standardization. Roland has a leadership role at VESA, where he serves as chairman of their High Dynamic Range Task Group. That group has developed and released the DisplayHDR criteria, which we'll talk about in just a bit. Roland, welcome to the Display Show.
Thank you very much, Brian. Good to see you again.
It's good to see you too. Maybe we should start with Intel. Most people think of Intel as a chip company, and I wonder if you can help our viewers understand why Intel has an interest in display technology.
So Intel has a long history, and historically it was a chip company. Obviously, we still make a tremendous number of chips, but we're a lot more than that. We're a data company. We build data center hardware, we build PC hardware, we build software, and we have an enormous number of people at the company building software. So we're involved in a tremendous amount of activities. And one of the activities that I'm involved in, and that a good number of people at Intel are involved in, is helping our ecosystem partners, helping encourage new technology across the entire industry to make the experience better for the end user. Because we can't just sell people on faster CPUs every year. We need to sell them with new technology and new exciting platform technology. So it's a combination of the CPU speed, the quantity of storage, the ability of the display, and a number of other variables, audio as well, that we can improve year after year, platform generation after platform generation, and encourage people to buy a new PC as a result of that. And so that's what I'm involved in, just working very closely with a huge part of the display ecosystem.
Okay, well, let's talk about VESA, which for those who don't know stands for the Video Electronics Standards Association. You and I have a lot of history back with VESA, and these days I'm wondering about how many companies are members of the organization.
Yeah, so I believe there's 320, maybe slightly above that now. So there was a big annual meeting a couple of weeks back, and 320 was the number at that point, and it continues to grow. I believe last year was one of the years of greatest growth. So the organization continues to add members. In addition to that, that's the number of member companies. Within that, each member company is eligible to have as many of their engineers or technicians or whoever wants to join the VESA work groups. And I think there were 4,600 members from those 320 companies that participate at least in receiving mailing list content. And many of those people participate in the various work groups to build out the VESA standards.
We'll put up the URL for VESA so people can get more information about it. I note that VESA has taken a great interest in high dynamic range technologies, and you happen to be chair of the Display Performance Metrics Work Group, which, among other things, is the group responsible for authoring of the DisplayHDR specification. Can you tell us about DisplayHDR, what it is, and why it's important?
There were a number of brands that were trying to start up HDR standards, and they were closed or very proprietary or limited to their brand only. And we recognize that what works well in the PC industry is an open standard that everybody can follow, consumers understand, and they feel the specs are trustworthy and they don't need to worry about one brand versus another because they understand the numbers. And so we wanted to go build out an entirely new HDR program that was open and public, full disclosure. And about 4 years ago, I looked around for various standards groups to determine which would be the most suitable standards group to go build out an HDR program, settled upon agreeing with VESA being the right group for this. And so we built a work group to go do that. And that became not just the HDR work group, but became the Display Performance Metrics work group. as the determination at the time was, well, perhaps we'll do more than just HDR. And that certainly now seems to be the case. So within that work group, our first task was to go build the DisplayHDR standard, or the standard that became DisplayHDR. And we had 30, 40 different member companies collaborate from VESA, build out the spec, and build an absolutely entirely open public standard. You can download for free the 80-page certification test spec. You can download the automated test tool for free from either the Microsoft Store or from the VESA website. You can download the template for the measurement values that you enter from the test tool into the template to determine if the hardware passes. And all of the criteria for passing the tests are fully public and on the website at displayhdr.org.
So we should talk in a little more detail about DisplayHDR. There are various performance or acceptance thresholds that have to be achieved to be qualified at different levels. We'll show the criteria here up on the screen, but I'll mention there was an initial v1.0 release, and a little over a year ago, there is a v1.1 version that came out. Can you talk us through these performance criteria and give us an overview of what these mean?
We published the 1.0 spec, I believe it was December of 2017. And so our first CES was January that next month, 2018, where we showed the first few products. And that was our first development of the spec. And I'm very proud of the effort that went into that spec and the development of that. But of course, after you launch something, you realize, oh, well, okay, we could improve a certain set of the criteria. We could improve things. We now have a better understanding of how to test more suitably. And so we improved the test criteria. One of the key differences for 1.1, and all of this information is at displayhdr.org. It's on the page under the performance criteria. But the first thing was ensuring that we have active dimming. So what that means is with an HDR system, and particularly if you're talking about an HDR system with LCD rather than OLED, which is a little bit different, but with an LCD where you have a backlight, the accomplishment of HDR is achieved by dimming the backlight so that you have control of both the LCD transparency and control of the backlight power. And by having the two of them work in collaboration, you can achieve far greater contrast level on the screen. Now, if you have a local dimming display, which defines a backlight that has multiple segments, you can use that to achieve greater contrast in the same image at the same time all at once. If you only have global dimming, then obviously you can't go beyond the native contrast of the panel, but you can have an increased contrast range between bright scenes and dark scenes, and you can achieve that with a global dimming backlight. So the first thing we wanted to make absolutely certain of is that in CTS version 1.1, we added a new test to ensure that active dimming was working. And the key element of what active dimming involves is we send a video sequence to the display, and we check that the black level of the display, which is fundamentally defined by the amount of light leakage that's occurring through the LCD from the backlight, we fundamentally check that the black level is declining when the peak luminance of the video declines. So specifically, we use a checkerboard. It's just traditionally it's a 4x6 black and white checkerboard. And you can put your optical sensor on any black square of the checkerboard. And as the white level of the checkerboard is brought down, you should correspondingly see a black level reduction of the black squares in the checkerboard. And that's active dimming. If that's operating without changing the metadata, and that's the really key difference. In the 1.0 spec, we sent a different metadata when we changed the luminance level of the checkerboard. And so you could in your algorithm of the scaler or the Tcon, you could just watch for metadata change and then change your backlight based on the metadata. But that's not how Windows works. That's not how a video plays. It doesn't change the metadata along while it's occurring. And so the critical test here was go check that this is actively analyzing each frame of video and determining what backlight power to use based on the video frame. The next thing was display ID or EDID accuracy. So previously, our color tests, we used to just send red, green, and blue color tests using 100% of BT 2020 red, green, and blue. But that's not how Windows works. Windows reads your EDID values and will dynamically tone map and color gamut compress the content down to the range that is stated in the EDID. And then we'll only ever send those color values to the display. It's not going to send 100% of BT 2020 to the display, unless, of course, your EDID says that. And so we wanted to switch our color tests to doing the color the same way Windows works, so that when you plug your monitor into Windows, our tests represent exactly what Windows is going to do with the monitor anyway. We also have new color gamut specifications where this was specifically designed to test for color volume. It's kind of a shortcut way to test for color volume, but we test the luminance value of adding the luminance element of the red, green, and blue together and check that that also exceeds the logo requirement. So if you have a DisplayHDR 600, we test a red image, a green image, and a blue image, and the combined total of those three luminance values needs to be more than 600 if you're at the DisplayHDR 600 level. And this was for the purpose of detecting if you were using a four-color primary of red, green, blue, white with a reduced color volume as a result of the white pixel just to achieve luminance. And so that was what this test was for.
That's kind of a color signal white test of sorts, also known as color light output. And that's useful because displays are more complicated than just RGB now. You have RGBW, and there's even some configs with RGBY that have been shipped. So that was a good test to add.
Yeah, exactly. And, you know, in some of the cases of RGBW pixel structure, they use the W for power efficiency. And so if you have a white pixel on the screen, they use the W, and that's great. I mean, if you can save power by using the white pixel for a white background, but you're not using the white pixel just to get to a luminance level, sacrificing the color volume, then that's a fantastic design. And we love seeing stuff like that because you get the power saving advantage and you've still got the full color volume. But this test verifies that you have the full expected color volume. So these are all the new requirements that are added in DisplayHDR 1.1. And if we then now go to the second half of your question of, okay, what's in the table and what are the requirements? So I've talked about the DisplayHDR 600. We actually have 7 different performance logos. We have a 400, 500, 600, 1000, and 1400, traditionally for LCD designs. And then we have 2 for emissive pixel technologies. So at this point in time, within the market, that's predominantly just OLED. It may become micro LED in the future, but today it's fundamentally entirely OLED, apart from a few designs. So that we have a true black marker or denominator for the emissive pixel technologies, and we have a slightly different set of criteria for that. That is focused around the fact that these emissive pixel technologies, in particular OLED, has absolutely fantastic contrast ratio, but typically cannot achieve full screen white at the same power level as LCD can. And so because of these 2 factors, we decided that a separate logo was suitable for this, so that we could delineate between the LCD versus the emissive pixels. So beyond the top line number of 400 to 1400, which represents a 10% patch test. So we do a 10% of the screen at this luminance level, the rest of the screen is black, and we test this for 30 minutes. So this is a long endurance test for a display to be pumping out potentially all the way up to 1400 for half an hour. This is really going to test the thermals in the display, and a good many displays will trigger a thermal protection and will start dimming the display if they're not capable of meeting these targets. The other test, which is frankly where the vast majority of televisions struggle with this performance criteria, is a full screen flash test. So we wanted to ensure that in a game or in a movie where you have an explosion, we wanted to test full screen white. You needed to be able to flash for 2 seconds at full luminance, full screen. And this is not a thermal test because it's only 2 seconds, but this is a power delivery test. And in most cases, the televisions are architected so that they are not going to be able to deliver full screen white at all, ever, even just for 2 seconds. So then we have the full screen long duration test, which we have a compromise of roughly, let's call it 60% of the logo level for the luminance that you need to be able to do full screen white for 30 minutes. So again, this is definitely a thermal test because you're certainly going to be heating up the display running it at full power for 30 minutes. Then there's the black level tests. We have 2 of those. We have a corner box test and then a checkerboard test. The corner box test is great for testing how dark can you get the screen with 2 white corner boxes and the rest of the screen is black. So 90% of the screen is black, 5% corners, and you get you can sometimes see 100,000 or even more than 100,000 to 1 contrast ratio in some displays with that test. The checkerboard test, that's much, much tougher. If you've got 1D or 1.5D local dimming, you can't do anything with a checkerboard. It's a native panel test. It's only if you have a 2D matrix that you can really shine in the checkerboard test. But we fundamentally, the majority of what we use the checkerboard test is for the active dimming test. And then we have the color test where we test the percentage of the sRGB color space, because still 90% of the content you're going to look at on a PC is within the sRGB color space. So we wanted to ensure that you have very, very good coverage of the sRGB color space. Then there's the DCI-P3 space, which your HDR content for movies is typically targeting DCI-P3 space. So any HDR movie content is going to be taking advantage of that. And we set most of our targets at 90%. We've started moving that up, and at the 1400 tier, that's 95% of DCI-P3. And beyond that, there's the BT2020 space. And we're starting to see some displays far exceed the 90% target of DCI-P3. And we're now looking at, okay, for any future iteration of the display HDR standard, we'll also be looking and measuring the BT2020 color space, as some displays are getting to 90% of BT2020, which is a tremendous display. So then we've got the color volume tests, or like I said, the shortcut to the color volume tests. And then we have requirements on, you've got to be able to take 10-bit video input and process 10-bit input signal. We have specific driver requirements for the driver IC. So this is the final silicon that converts your digital into analog. And we wanted to ensure that that was at least operating at 8-bit. And the +2 dithering that you can see in the table is implemented either in your Tcon or your scaler. to add dithering, either temporally or spatially, but some form of dithering is required. And then we have the requirement for the backlight also needs to be to 8-bit accuracy. And then there's a rise time requirement. This is the speed at which the display needs to operate. And so if you have a firework explode, for example, or a gun blast in a game, you can't wait half a second for the backlight to light up before you have the full luminance. So we set some specifications as to how quickly the backlight needs to rise from black to full white and measured in frames. And then we have white point accuracy.
It's a lot of information, Roland. The technology is always improving, and I think our viewers are likely interested to understand, with luminance going up, color getting into greater depth and more saturation, and all the various display improvements that we see happen year over year. I bet our viewers are going to be interested to know when VESA plans to release the next version of DisplayHDR and what you expect the areas of focus to be. Can you give us a sense of the approximate timing of the next release or releases and what you expect will be included?
Yeah, so I can definitely approximate. It's very, very hard to set a specific schedule to things. But within the display performance metrics work group, the work group that I lead, we have two other standards and activities that we're currently working on. One is related to the quality of motion blur, so the speed at which a display can transition. So we're working on a spec for that. I think that is likely to be the next one that comes out of our work group. And then after that, we're also working on standards for adaptive sync. So VESA has invested a huge amount of time and effort on developing adaptive sync, which is the control of variable frame rate over DisplayPort. So we have other front of screen display performance characteristics for those two specs that we're working on first. And then we will likely, after those are concluded, move into the next generation of DisplayHDR. So I would guess we won't see another version of DisplayHDR until 2022, because I think we're going to be spending a first half of the year probably to get these other two standards out, and then the latter half of 2021 working on the DisplayHDR next generation.
So, Roland, thanks for sharing all of this information about DisplayHDR. I wanted to know if there is a DisplayHDR certification program for manufacturers to qualify their products at the different performance levels.
Oh, absolutely. Yeah. So what I would recommend is go to the displayhdr.org website, download the test tool, run the test tool in-house. You only need a colorimeter probe or spectroradiometer to take the measurements. And you could validate that everything you have in your firmware is operating correctly. And then once you're confident that it's going to pass certification testing, then as a new OEM in the program, you would then send your monitor to the third-party test house. They would validate your test results and their test results are similar. And once you've got that, then it would be certified. And then it would go up on the website along with the other, I think we're close to 600 certified devices. And so your device would get added to the list on the certified products page. Once you have been through that process several times and proven that your test results match the third-party test house to sufficient tolerance, then we deem you capable of testing reliably. And at some point, we give you authorization to do in-house validation.
So at that point, it becomes self-certification?
Yes.
I see.
Yeah. But at any point in time, we have an audit process. So VESA purchases hardware, validates that it meets the performance. And if we get any questions from other OEMs, competitors, or customers, then we do validation. And it's a fairly straightforward process, and we have all of the process in place to handle those kind of audit outcomes.
I see. So consumers can generally have confidence that if a product
absolutely
has the certification, or if it claims a certain display HDR performance threshold or level, that's what they're actually getting.
Yes.
Okay. You know, VESA has traditionally covered IT applications, more so than TV and other consumer products. Do any manufacturers plan to apply display HDR for consumer applications?
So they're all consumer applications. I mean, many of these monitors are being used for home PCs, for gaming, for photo editing and such, but I believe your question was more related to televisions. But in the television space, we absolutely have television-sized monitors that have been certified. And really, the difference, quite honestly, between a television-sized monitor and a television is the absence of a TV tuner, which, as relatively few people attach a antenna to their TV, there's not really much difference. You know, a lot of TVs don't really need the TV tuner if you're going to provide a signal source from whatever consumer streaming box you may be using. So they're very, very similar hardware. As I mentioned earlier, I think where most of the televisions struggle the most with our spec requirements is the full screen flash. And the TV is 1,000 nit TV is typically simply not designed with the power delivery to drive 1,000 nits full screen, even for 2 seconds. And so the TV size monitors that are certified, and there's plenty of 49-inch, 55-inch, even 65-inch monitors that have been certified. Those manufacturers have gone to significant additional effort to ensure that they've got the power delivery to drive the full screen for that flash period at least.
Okay, well that's helpful. Turning back to Intel, can you say a few words about which Intel CPUs support HDR and which operating system versions come into play?
Yes. So from a integrated CPU GPU perspective, Intel has been shipping HDR capable CPUs since January of 2017. So 4 years. All of our KB Lake, Whiskey Lake, Coffee Lake Refresh, Ice Lake, Tiger Lake, and now Rocket Lake all support HDR. So that's all of our CPU line for the last 4 years using our more recent graphics technology. So one of the big differences within those CPUs is the power efficiency. So the first generation of CPUs that we launched to support HDR, it was a very, very memory intensive operation to achieve that. And so the power efficiency to enable HDR was not entirely suitable for laptops. So it was really mostly a desktop activity. You could certainly do it on a laptop, but it would have an impact on battery life. We fundamentally re-architected the CPU-GPU combination to dramatically improve that, starting with Ice Lake. So Ice Lake is what we retail as our 10th generation architecture. So if you're looking for a laptop, anything with 10th generation or 11th generation is HDR capable and power efficient. Prior to that, It could do HDR, but it wouldn't have been as power efficient. So that's really the distinguishment there. Now, from an operating system perspective, I think if you look into Windows 10, because Microsoft uses the same name for multiple versions now, everything is Windows 10. And so you have to talk about the build version. And every 6 months, they update at a major level. So every 6 months, you get a new build version number in the Windows operating system. And I believe it's since the March 2018. So that's called 1803. So everything since version 1803 supports HDR.
Okay. So when you say supports HDR, if I've got a Blu-ray and it's got a PQ encoded EOTF, I can hook that up to my PC system and I'm in business.
That's a whole different category of request, an optical disc. You'll find relatively few Blu-ray optical discs in PCs, almost to the level that's such a small micro fraction of the PCs that are HDR capable that I really wouldn't focus on that. The HDR usage on the PC is streaming movie content from Netflix, for example. YouTube has a huge amount of HDR content. So those are two major streaming sources. And of course, PC gaming. The vast majority of AAA game titles are HDR enabled. And so that's a huge part of the HDR usage model. And the great thing about the gaming is the games will dynamically use whatever HDR luminance range is stated in the EDID. It will dynamically utilize the full color gamut. So you're not limited by sRGB. You're not even limited by DCI-P3. It will use the full color range of whatever your display can achieve. So if the display has the correct EDID, the EDID goes to the GPU forwards that onto the game, and the game is going to take full advantage of the color range. So that's a really fantastic usage to demonstrate extreme color in the PC gaming space. And then there's more recently, there's video editing as well. So there are at least 3 major software apps. There's Blackmagic's DaVinci Resolve Studio. There's Magic's Pro X, and there's Adobe Premiere Pro that now all support HDR video editing.
You know, it's such a huge improvement in terms of the visual experience for users, gamers, consumers. This is big news. I've got to ask you another question about Intel, and that's as of January of this year, it's 2021. Pat Gelsinger has returned as the CEO. How do you feel about this and Intel's future direction?
I think it's a very good news for us. Pat had been at Intel for 30 years before he left in, I think it was 2009. So he had grown through the company all the way up to CTO and left, gained CEO experience to a large company, VMware, that he's coming from. And so he comes back to us with an absolutely amazing knowledge of Intel. He is an extreme technologist. And now with CEO experience, I think he's going to be a really wonderful opportunity for us at Intel. And I'm looking forward to it.
Well, congratulations on getting him back.
Yeah. I think it's very good news for us. Yeah.
Well, I have a final question for you because this is the display show. And I guess what I'd like to know is what future display directions Intel would like to see. You know, what technologies and improvements does your company consider to be important?
So we look at what is most impactful to the end user. And we're, like I said at the very beginning of the show, my activity is to try and identify what is going to have the most value to the end user that will encourage that end user to go buy a new display, new PC, refresh their older hardware, and get some new wonderful experience. And certainly within the HDR, and to put some numbers to your earlier statement that HDR is a tremendous difference. What you often see on, say, a DisplayHDR 1000 display is you see something that has perhaps double the color of what you used to have, triple the luminance of what you used to have, and 10 times or more greater black level than what you used to have. So you multiply this together and you've got this absolutely incredible display capability compared to what you may have been used to on an old standard dynamic range display.
Yeah, people don't understand, but HDR is not just about brighter.
Right.
Yeah,
it's so much more than brighter. It's, brighter, okay, we've got 3x brighter, but you multiply that by 10x darker and you multiply it by the increased color. And it's a lot more than 3x difference. It's a truly astounding difference. So what we're trying to do, and certainly in one of the next standards that we're driving through VESA on the adaptive sync capability, is to align the GPU frame output to the clock of the monitor. And rather, more importantly, instead of having the monitor drive the frame clock, we use the GPU to drive the frame clock, which means you eliminate tearing, you eliminate a substantial amount of latency, and the frame is always delivered as quickly as possible. Clearly, this is obviously good for gaming. The other piece that I want to get this into is video playback. So for many, many, many years, we've had the problem of anytime you're watching Hollywood content filmed at 24 frames per second, played on a 60 hertz display, you end up with this 3:2 pull down issue that creates judder. And we want to eliminate that. By using adaptive sync, we can entirely eliminate the judder caused by 3:2 pull down by eliminating 3:2 pull down itself and synchronizing the display to the frame rate of the content, or an integer multiple of the frame rate of the content to optimize for flicker as well. And so that's some of the new activity that we're working on, ensuring that the display hardware, the GPU hardware, and the operating system all cooperate together to achieve this. Now, what makes this so much more difficult than what the television guys have to deal with is we don't just have one content source. You have multiple windows on the screen. So what are you going to do if you're running a game and running a movie on the same screen at the same time? Which frame rate is the right frame rate, the correct frame rate to go use? Or if you happen to be video editing some content at 24 hertz, but you're watching some training video on YouTube at 30 hertz, and what do you go do? I mean, in that case, the answer is pretty easy. Run it 120, and you've got integer multiples of both. But in many cases, the answer is not quite that easy. And so there's a certain amount of logic that has to be developed to optimize the display so that you can eliminate judder in as many cases as possible.
And this is a real situation. You might have some picture-in-picture situation where you're mainly focused on one piece of content, but meanwhile you're previewing, or maybe you're waiting for something else to happen in the other window, and just because they're streaming out of different formats doesn't mean that one of them can look like junk and then the other one looks good. You want them both to look good. So that's a very real use case scenario that you've just described.
Right. And picture-in-picture, you don't use that too often on a TV, but on a PC, 90% of the time you have multiple windows. So it's an extremely common use case for us that we have to deal with it.
This isn't some weird corner case situation. No. It's all the time.
Exactly. Yeah, so I'm very encouraged to work with the HDR technology and the adaptive sync. We also have some motion blur activity occurring as well. So all of these combined will, in the end, result with absolutely phenomenal displays. that will truly impress anyone.
Well, this has been a fantastic discussion, Roland. It's so helpful, and I think that our viewers will be really encouraged to hear about these improvements that are coming along, and also how there's a set of standards that can guide the process. And
Right.
we look forward to hearing more from you and from VESA and from the industry as new ground is opened up and improvements continue to happen. The technology moves so fast, and it's helpful to speak with people like you who understand it and can help everyone to follow, because you have to stay on top of it. Thank you so much for being a part of the Display Show and taking time to speak with us today. Really appreciate it.
Well, it's been a pleasure, and thanks for having me on.
All right, and that's a wrap for now.
Okay.
And look forward to seeing you in person before too long.
Yeah, let's hope so.
Thanks, Roland.
Okay, see you.
Bye.